take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't.
The industrial history of the United States is not just a collection of dates. It is a story written in cold steel and the sweat of generations. We begin our journey with a 1967 Volkswagen Beetle, a bug that has surrendered to time. For decades it sat silent, an abandoned relic of an era when manufacturing was defined by Fordist simplicity and manual labor. This car is a ghost from the American heartland. It reminds us of places like Moraine, Ohio. Since 1926, that ground has seen the evolution of work, from Frigidaire refrigerators to massive GM truck lines that produced over 6 million vehicles between 1981 and 2008. When the 2008 financial crisis shuttered those gates, it felt like the end of the industrial dream. But in 2026, we operate under a new philosophy. Old things never die. They simply wait for the technology to catch up with their spirit. We are not here for a simple restoration. We are here to perform a digital resurrection using physical AI, a technology that allows machines to perceive, decide, and act autonomously in the real world. Our Beetle leaves the rust behind and enters the gates of the Samsung Taylor Plant 1 in Texas. It is impossible to overstate the magnitude of this facility. Spanning 4.85 million square meters, this is the largest chip manufacturing site on the planet, surpassing the legendary complexes of Pyeongtaek and Hwaseong combined. 7,000 workers built this cathedral of silicon to anchor the 2-nanometer era on American soil. Inside, the environment is sterile, governed by a logic that operates at the atomic level. As the Beetle passes through the high-velocity airlocks, it is being prepared for a mind far beyond its original design. This is where the old world meets the pinnacle of human precision. In March 2026, this facility began testing the most complex technology ever mastered: extreme ultraviolet EUV lithography. Each machine here, costing roughly $339 million, uses beams of light to etch patterns so small that a single speck of dust would be a mountain on its surface. We are here to install the nervous system of the future, the Samsung AI6 processor core. This is not a standard computing unit. It is forged using 2-nanometer gate-all-around GAA transistor architecture. Unlike the aging FinFET designs, GAA wraps the transistor channel on all 4 sides. This design provides unprecedented control over electrical leakage and power efficiency, reaching a point where the boundary between hardware and thought begins to blur. This specific AI6 silicon was part of a landmark $16.5 billion contract, originally intended for the world's most advanced autonomous vehicles. Today, it finds a new home in 1967 steel. We are witnessing the closing of the maturity gap. While traditional GPUs are now mature commodities, the industry is racing toward Agentic AI, systems that don't just process data, but plan and execute complex, multi-step tasks across physical environments with minimal human supervision. The question is often asked, why now? The answer is not just technological, it is economic. On July 4, 2026, the industrial landscape of America changed forever with the signing of the One Big Beautiful Bill, OBBB. This $3 trillion act became the green light that manufacturers had been waiting for. Under the OBBB, the rules of the game were rewritten. Companies now benefit from 100% immediate expensing on high-tech equipment and industrial robots. In the past, a robotic cell was a long-term luxury with a 5-year tax depreciation. Today, it is a year-one tax asset. This bill demolished the barriers to entry for small shops and innovators. It turned the dream of autonomous restoration into a logical business decision. By restoring the R&D expensing and doubling the Section 179 limits to $2.5 million, the government didn't just fund factories, it funded a revolution in productivity. The labor market is facing a harsh reality. The average welder in the United States is now 40 years old, and younger workers are not filling the gap fast enough. Automation is no longer a choice. It is a necessity for survival. Enter the Standard Bot's R01. This robotic arm is a masterpiece of collaborative engineering. It operates with a repeatability of ± 0.025 millimeters. Watch as it performs a mechanical ballet, weaving the Beetle's new high-voltage nervous system with a precision that makes human error a thing of the past. This is the core of the 2026 Industrial Tech Radar. Smarter robots for a brighter future. By using physical AI, these arms can automate tasks that were once deemed impossible due to their complexity or environmental unpredictability. The R01 doesn't just follow a script, it perceives the steel, adapts to its imperfections, and completes the mission with unreal simplicity. The industry is undergoing a silent but massive pivot. Across North America, 10 major battery plants are being modified and repurposed. They are no longer just producing simple EV batteries. They are building energy storage systems, ESS, the vital infrastructure needed to feed the insatiable power hunger of AI data centers. Our Beetle is a micro-reflection of this shift. As the R01 arms install Samsung SDI battery modules into the chassis, the car transforms from a simple product into an intelligent energy node. It is becoming a subject of autonomous workloads. In a world where continuous power is critical for server stability, these ESS complexes compensate for the instability of wind and solar generation. By integrating this technology, the Beetle becomes part of a distributed mesh network, an active participant in the energy economy of the Texas desert. We have reached the moment of activation. A finger taps the glass. Initiate Agentic AI. The interface pulses with a vibrant orange glow, the same hue as the EUV light that birthed its processor. Inside the empty cabin, the steering wheel begins a ghostly, autonomous calibration spin. There is no human driver, yet the car is waking up. This is the transition from connected operations to a fully autonomous environment. This is physical AI in action. Unlike standard software, this system can model its physical environment contextually. It reasons about its position, its identity, and its relationship to the world around it. As the Beetle glides forward silently, its glass headlights flicker and surge with a warm, powerful beam, symbolizing a machine that finally sees the path ahead. The Beetle moves across the polished factory floor, a tiny black dot against the monolithic 6-story Samsung complex. It is no longer an intruder in this high-tech world. It is a peer. It is greeted by a community of autonomous mobile robots, AMRs. These machines, using advanced sensor fusion and vision language models, salute the car by flashing their LED arrays. They recognize the 2-nanometer logic that now governs the Beetle's every movement. We are witnessing the realization of a path toward fully autonomous systems. Industrial technologies are moving beyond simple data sharing into platforms that orchestrate complex workflows across entire sites. In this ecosystem, the Beetle is not just a car, it is a mobile AI workload perfectly optimized for the infrastructure that surrounds it. The Beetle leaves the facility behind and enters the vastness of the Texas desert. At dawn, the air is crisp and the sky is a gradient of deep teal and gold. The mirror-black paint, polished to a liquid finish, captures the first rays of the sun. The dashboard display confirms the status: 6G connected, physical AI optimized. Through a satellite 6G link, the car is constantly syncing with the industrial mesh, a feat of connectivity that was only a horizon dream a few years ago. A hand in a weathered yellow glove rests on the roof. This is the symbol of the bond between man and AI. We are not just passengers, we are coexisting with a system we have taught to care for our heritage. The math of the One Big Beautiful Bill has tilted the momentum back toward American innovation, making this triumph possible. The Beetle heads directly into a vibrant orange sunset. As it moves, its black surface turns into shimmering gold, reflecting the light of a new era. It begins to disappear into the heavy heat haze of the desert road. The era of hands without brains, the era of manual, repetitive labor that defined the 20th century, is officially over. In its place is a world where history and 2-nanometer innovation drive together into the future. The car vanishes, leaving only the silence of the empty road. But if you listen closely, you can still hear it. The faint, rhythmic digital pulse of the AI core echoing in the stillness. Old things never die. They simply become the heart of everything that comes next.